Hi everyone, welcome to April 20th Math 8, and we're starting a new chapter. We're in Chapter 8, Three-Dimensional Figures. This week we're going to be looking at 8.1 and 8.2, and that information is going to correspond with the email lesson plan that I sent to your parents today. Hopefully they received that. And the next packet you'll receive, Packet 3, will address the rest of this chapter. And so you'll be getting that at the beginning of next week along with the new lesson plan. So again, let's look at this first section. All right, so our first section is about three-dimensional figures. And so I'm going to play this clip, part of this clip from Anywhere Math for you to watch.
Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to talk about three-dimensional figures. Whoa. Let's get started. All right, for today's lesson, there's going to be a lot of terms and a lot of pictures and drawings to make, so make sure you take really good notes. Okay, so today we're talking about three-dimensional figures. And before we get to any examples, there's quite a lot of terms and vocabulary words that we need to talk about. So first, if I look at all of these, well, what are they? Well, we call them solids. And solids are three-dimensional figures that take up space. We've got a cube, a pyramid, triangular prism, we got a cylinder, a cone, and a sphere. They're all solids. Some of these look like they might belong together and some of them don't, okay? The next word we're going to talk about are polyhedrons. Well, which ones of these are polyhedrons? Polyhedrons are three-dimensional figures, right? But all of the faces are polygons. So that means if there's anything that looks rounded, like a sphere, it's not a polyhedron. So this doesn't work. Cylinder is also not a polyhedron. Cone, not a polyhedron, right? It's rounded on this part here. The base is a circle. That doesn't work. But these ones left over, yes, pyramid is definitely a polyhedron. Cube, for sure. Triangular prism, those are all polyhedrons. All of these faces are polygons. Okay, next, we're going to take a look at a cube and talk a little bit more about some more vocabulary words to describe this cube. First word we're going to talk about is face. Well, what is a face on a polyhedron? We're not talking about a face like this. Face is like a side of a polyhedron or a 3D figure. So if you look at this cube, how many faces does it have? Well, we've got the front and the back, that's 2. We've got the left and the right, that's 2 more, so that's 4. And we got the top and the bottom. So altogether, this has 6 faces. Next, let's talk about this part right here. We call this an edge. An edge is where 2 faces meet. That's all it is. So we've got an edge here where this face and this face meet. Edge right here where this face and this face meet. So if we look at this cube, how many edges does it have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, and on the bottom, 9, 10, 11, 12. 12 edges in this cube. Next word we're going to talk about is right here. That's called a vertex. And a vertex is where 3 edges meet. So right here, this vertex, there's an edge, and an edge where they meet. That's called a vertex. Well, how many vertices, that's plural for vertex, does this cube have? So let's see. We've got 1 here, 2, 3, 4, and then on the bottom, 5, 6, 7, 8. 8 vertices. Here's one to try on your own.
Okay, just to review the vocabulary that you just saw, a solid is a three-dimensional figure that encloses a space. A polyhedron is a solid whose spaces are all polygons. A face is a flat surface of a polyhedron. An edge is a line segment where two faces intersect. A vertex is a point where three or more edges intersect. In a visual, I took a picture of our textbook. Here again, a solid is a three-dimensional figure that encloses a space. A polyhedron is a solid whose faces are all polygons. And then you see the labeling for each: a face, the edge, and the vertex. Let's go ahead and look at our example in our textbook. Okay, example 1 says find the number of faces, edges, and vertices of the solid. And so the solid has one face on the bottom, one face at the top, and four faces on the side. And the faces intersect at 12 different line segments. The edges intersect at 8 points. So the solid has 6 faces, 12 edges, and 8 vertices. Let's take a look at the tutorial.
Find the number of faces, edges, and vertices of the solid. The solid has one face on the top, one face on the bottom, and 1, 2, 3, 4, 5 faces on the sides. The faces intersect at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different line segments. And the edges intersect at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different points. So there are a total of 7 faces, 15 edges, and 10 vertices.
Okay, so the next part is asking you the on your own question. So you could be asked a question about this. Find the number of faces, edges, and vertices of the solid. And so you would see that this, the answer would be 5 faces, 9 edges, and 6 vertices. I'm going to stop today's, this part of the lesson for today right now, and I'm going to ask you to rejoin on part 2. So this is the end of part 1. Please now rejoin and click on part 2.